Hello, everybody. This is going to be a quick demo on how to get going on the extension, the Minesweeper extension. So you sort of find it right here on our page, and you can see, for those of you who are not familiar with this game, you can look it up. But the idea is that you're going to generate some mines in this field, and then you sort of give the solution to the output that you commonly give to the user when they click on something is whether or not they clicked on a mine, which is the end of the game, or if you didn't, how many of the surrounding locations, the adjacent locations have a mine. And so for this particular board, you can see that this is the output, right? Because this spot has no mines and is not a mine and doesn't have anybody around it. This spot isn't a mine, so it's a number, and it has these two in adjacent spots. And this one is obviously 3 because all 3 of those. This one right here is a mine, so it is a mine. It doesn't matter how many are adjacent to it because it is in fact a mine. And so you're gonna solve this problem. So if you have cloned your repo, you'll find inside of this project, there's in the source directory, you'll find a package for every single one of the extensions. And here in Minesweeper, you'll find a number of files, but Minesweeper is the one that you're going to edit. And you can see we've started this out by having an ARGS processor asking how many columns and how many rows are going to be in this, and what is the probability that each cell will have a mine. And so you're supposed to write this fantastic code below here that's going to produce output depending on the rows and columns that matches this. And we're going to read that output in the test suite and try to give you quality feedback based on that. And so right now, what I would like to do is, like, if we run this test suite right here, if I can right click on it and run as a JUnit test, since we haven't written anything, as you might imagine, we fail all the tests, including the probability tests. These are sort of checking to produce that the board is somewhat reasonable. And these are checking to make sure that the probability is within some range, right? Like, so like if we say to have 45% mines, is there some reasonably close version of that? And so this is obviously wrong. If I were to totally ignore the output, and obviously you will not write a program like this, but write the shortest possible one, which is like, oh, there's a bomb and it's right there. You can see that we may even, let's see if we even pass the first test. I'm not sure. Yes, we're going to pass all these tests, right? Like where there's one in there, there's like, well, that's a reasonably formatted minefield, right? Like this one should also pass those tests, right? This one wouldn't because there won't be anybody around it. I don't want to get into this too much because this is obviously a ridiculous version of this code, but I want to sort of show you how to, oh, that's going to run it, but let's run the test suite, how to grok or how to interpret this. A lot of times you can take information from not only like what I'm not passing, but what I did pass. So in this case, so I passed all the column count 1, row count 1s, but now I'm failing once there's 2 rows. And it will tell you, we're not even printing the right number of rows in this situation, right? Or, and so, it was expecting this information and we actually only got, it was expecting 2 rows and we only got 1. This is what you printed. It's not as enough rows. Now we could continue by like printing more of this, but that's not really going to be too helpful. Now what I'm going to do next is to get sort of to a more interesting state, something that's built a lot more of this, but not quite correct, is you can see in my Git staging area, I committed a almost working but somewhat broken version of this. So I can right click on this file and replace with the head revision. That will go back to the last version that you committed. Git is a fantastic tool. And one of the things is you can always commit and push any version of the system you want, and you can always go back to that. The easiest one to go back to is, of course, the last one. The solution to this is below, but we won't show that to you because we don't want you to miss out on building this extension. But if I run this now, you'll see we're going to pass a bunch of tests, but not all of them, right? And so looks like all of those passed, and we can try to make sense of this. It's like, oh, if I click, maybe sometimes the bigger ones are easier to make sense of, right? These are what I actually printed out for this test, right? And it's like, it can be a little difficult to figure out. So we built you a debug app that will hopefully help with this. So I'm going to run this as a Java application. And you can see, I'm going to just maximize it here. This is the we sent in 9 and 5, so 9 columns, 5 rows, and 0.25 probability, right? And you produced this output. And we rendered it up here, and you can see that some of them are working and some of them aren't. And so the idea here is we're going to try to give you some help. It's like, oh, so that is row 0, column 5. We printed 2 and it was supposed to be 3. And that makes some sense because if you can look, there's a bomb there, a mine there, there, and there. So that one should be 3. I'm missing something here. And so one of the things you can do is you can grab these sliders and add more rows and more columns and try to get the sense of things. But as I tweak this, right, you can see, hopefully, you can also press this button down here, which will just regenerate it. So it reruns your code and sort of sees what it prints out and it shows it this. And you can see, hopefully, in this whole thing, you can change the probability over here. No matter what I do, if I crank this probability down to 0, it'll work. But like if I have anything, something is going on wrong in this top, either 1 or 2 rows. Now, what actually happened is I was skipping the top row. And so you can see that, you know, this guy should be 2 and it's registering that one, but not that one. And this one should be 2 also, but it's not counting this row either. And so hopefully this, when you get past sort of producing a reasonable board, but it's not quite working, you can go to this program to help you sort of debug your what is going wrong. And again, you can sort of look over each one and see, I'm printing 3, but I expected 4. And you can look at this and sort of figure out what it's supposed to be. When you're done with all that, there's actually one last thing, which is the Minesweeper game, which is a version of this that Professor Citra built a long time ago, which actually lets you build, which actually lets you play this. You know, like I click there, and this is how the game usually works. If you click a 0, it'll fill out all the way to the end. And so I happen to know that each one of these has 1 mine next to it, and these both have 1 mine next to it. So I know that's it, and that's actually the solution. So that was a really easy board. Maybe I should run it again. Run as, and I'll maybe make a few more. Let's make it 6 by 6 and give it a little bit more higher chance of a bomb, 0.4%. Now when I click on things, let's see, we got 1 next to there, and then I hit a bomb and I immediately died. And so you can see it was printing out here, so it could have actually gone through it. But hopefully you'll have fun with this extension. Hopefully these debugging tools will help you. Again, don't just look at it as, oh, it doesn't work. Sometimes it's good to just look at your code and try to figure out what's going wrong. There's nothing wrong with that. But every now and then it's nice to use these tools to help you find clues, to help you figure out what went wrong and where. So good luck with this extension. Hopefully it'll go well. If it doesn't, we'll be here to help.